Okay. Um, so Google Colabs is just a very useful service, and it can help you do a lot of cool stuff. So just to begin, so sorry, my little sister is banging in the background, but so this Google Colabs intro is a just a Google Collaborator notebook. I'm going to send it in the chat. You guys can open it up. I can open that up, and it's just like an intro notebook. So I'm going to give like 10 seconds. Okay, so pretty much what this is a Google Colabs notebook, and you can write code cells. So for example, if I want to write code, I can just press plus code or plus text, and you can write code and documentation in here straight up. So first, for example, we have this Python code cell here that helps us find how many seconds are in a day. So we can just easily press run, and it'll run that and print it out, hopefully. So we can see there's 86,400 seconds in a day, which is correct. And it's very easy to use. Just press play and it just executes it for you. So, and the good thing about Google Colabs is each cell is they're like all global. So variables that you define in the global scope can be used in following cells. So for example, if you want to find out the number of seconds in a week, we can just multiply the seconds in a day by 7, and we can see that it's 604,800, which is also correct. So with documentation, you can add images, HTML, and the famed LaTeX word processing environment. So when you create your Google Colab notebooks, they're stored in your Google Drive, so you can easily access them. And yeah, so here's the cool thing about Google Colabs is that everything's already installed, so you don't need to you don't need to do like pip install numpy or do any of that stuff. So we can see here that we can just import numpy, and you can just directly access the library. And so if you want to say install a specific version of a package, then you would have to use the pip install. And then in order to do that, you want to use this exclamation point. So this tells Google Colabs that we're going to be running in the command line. So if I do this, you'll see that it'll start collecting the numpy, but I don't want to do that because I want to keep numpy as the latest version. So you can easily switch between command line code and then Python. And Google Colabs does it seamlessly. So with data science, you can harness the full power of Python libraries, and visualize data and stuff like that. So here we can use the matplotlib library to draw a plot. So if you press play, we can draw a plot, and then if you see if we like, for example, edit some parameters, then it'll change. So this just changes the x-axis to 100, whereas before it was like 500. So it's very easy to use. You just type in Python code and you can execute it, and it does everything in the cloud. So it doesn't matter what type of machine you have as long as you have a web browser. So here is just some machine learning resources that you can use. I'm not going to go over this because a lot of this is fairly advanced. So talk more about that next workshop. But so for now, you guys can play around with this collab document. I'll give you like around 5 minutes. And if there's any questions, feel free to ask or PM me directly. So yeah, so we'll start back up around maybe like 5:28 probably, since this isn't too difficult. So yeah. Oh, and also, if you want to terminate processes in case you get like bugs and stuff, then you can just go directly to runtime, and you can either restart the runtime, interrupt execution, or if you go to manage sessions, then you can like terminate which sessions that you want to terminate. So this will like completely reset the whole environment for you. So if there's any like packages that you accidentally installed, that'll fix that problem. Yeah, if anyone has any questions, feel free to ask. Oh, and hopefully while we're waiting, you guys have like Python and like Git already installed in your computers. So here's like a link to install Python. We want to get at least like version 3.5 so we can use the TensorFlow library on it. So here is Python 3 installation link as well as Git. So Git will help us grab repositories from GitHub, which we can use to label training data as well as get examples from other people. So that's nice. So you can get a lot of open source libraries and projects to look at and experiment with. And if you don't want to install Git, that's totally fine too. Just whenever you see me typing git clone and then the URL, you can just go to the URL and download the zip code from there and extract the files. But that's just kind of annoying, so it's easier to use Git. Okay, so it's 5:28, so let's go to the next notebook. Right here. Right here. So if we go here, this is a mask RCNN camera demo. So this notebook is going to be using our webcam as well as a RCNN neural network. So this NN is like stands for neural network, and RC is a type of neural network. And mask means that, as you'll see in the object detection, it will put the masks on the objects, which means that like it'll highlight the specific objects that are detected. So how this pretty much works is like before, we're just going to be running each cell, and I'll explain what they are. So this is kind of like a bit more documentation. So first, when we set it up, we want to make sure that we're in a directory that's empty. So when we get clone this stuff, it's not going to give us an error. So it's good because we just have sample data. And then this %% shell just tells Google Colabs that every single one of these commands are going to be running in the command line. So you don't have to write exclamation points for every single line. So if we run that, it's going to clone this repository. So this is a just a project on GitHub that is a pre-trained model for the object detection. So then after that, we want to CD. So CD means just change directories and get into this new folder that we just cloned. And then after that, we're going to do Python setup.py install to set up the neural network. So if you guys have like any questions or any like things you don't understand about the syntax, I'll be happy to answer. And then after that, we want to make sure that we're in TensorFlow version 1 because TensorFlow version 2 doesn't support object detection. I don't know why. I think they're still working on that. So hopefully Google can pull through. And then after that, we want to just import all relevant packages. So operating system, NumPy, because NumPy is a very important library when it comes to doing machine learning because we need to manipulate all types of mathematics, and we'll need NumPy arrays to store images, but I'll go over that later. So then all of this stuff is pretty much just setting up the project. So setting the root directory into this folder so we can reference that later. And then we need to import the mask RCNN to this root. We need to import this mask RCNN directory to the path. So what the path is when you're calling command line scripts or when we're importing packages, we want to make sure that this mask RCNN is on the path. So then the Google Colabs and the Python knows exactly where to pull this MRCNN library, because this is not like a basic library like NumPy, for example, or skimage. This is like a specific project that we just imported. So we want to add this to the path so that when we import the specific project, it knows where to go and look for that. And then this is just the same thing. We're just adding the configuration file to the path so it knows where to find it. And then this is just saving adding a directory to save the logs and wherever the model is trained. And then here we're just loading in the directory of all the images and stuff like that. So I think I already ran it, but do it again just in case. Okay, I think I already ran it, so it doesn't need to do anything anymore. Yeah, so this is the configuration class. So we only need to use one GPU at a time, and then since we're going to be processing only one image at a time, we're just going to set that to 1. And then this is just creating a new configuration object from the inference config class that is defined above. And config.display is just displaying all this stuff. So yeah, if you guys have any questions or anything, feel free to ask or PM. And then next we need to create the actual model and then load the trained weights. So what this is going to do is create the actual mask RCNN model in inference mode. So this will allow us to predict and sort of classify objects. And then these other two parameters are just loading in the predefined model and then the configuration file that was defined above. And then next we need to load the weights. So since this is a pre-trained model, it has weights that are already defined. And this is in the COCO model path. So pretty much what a weight is in a neural network architecture, you have different layers of neurons. So I can have one input neuron and then another one, and then this first neuron will connect to the second one, and then say the second one has a third one and it'll connect. So what the neural network does is when it takes in inputs from the first neuron, it sends these to the second neuron, and then the second neuron plays with them and sort of modifies it. But sometimes different neurons have different weights to them. So sometimes some neurons are more important than others. So this is just loading all of the weights. So the weights can just be coefficients on each neuron. So some neurons, the neurons that are more important have bigger coefficients. And then when we load them by name, this just is making it load in order. And then so this is good. Even though we have warnings, there's no errors, so it's fine. And then next we have the class name. So in object detection, we need to define the objects that we're going to be able to detect. So for example, we have person, bicycle, car, motorcycle, etc. So there's, I believe, 90 classes in here. So 90 objects that are 90 unique objects that our model will be able to detect. So now we can just run the object detection. So what this does is loads a random image first by using this line of code just loads a random image, and then this takes the this uses the imRead method from the skimage.io library to change the image. So here's where the image is found in this path, and it changes this image to a NumPy array and then passes that into image. So a NumPy array is what the model can use to run object detection, because TensorFlow you can't just send an image into TensorFlow. You need to change it first into a NumPy array so that it can read it and put the numbers through the neurons. So why is the file name's random index image 2 rather than 0 or 1? Yeah, I believe this is because the image directory is found here, but calling the next function allows us to get this next function returns a different thing, and we need to use the third element of that array, so that's indexed at 2. So after that, we need to run the model.detect method, which helps us just detect the images or the objects in the model, in the image. And so this verbose parameter means the amount of sort of narration that the model does while it detects it. So if I put this as 0, you'll see that it shows nothing of the progress of the detection, but when I change it to 1, it'll show that. And then so all this does is just visualizes the models, visualizes the results. So we display the image as well as the masks, the class IDs, and the scores. And the scores is just the confidence level of the model. So if we load this, as you can see with verbose 0, it just shows us the warnings and it doesn't do anything else. So we have no idea the current progress of the detection model. But once it loads, oh, I never ran this. Oops. Okay. once you detect it, you'll see it gets a random image, and you can see that it detects some people with 100% confidence, while other people with 99% confidence, and some handbags, benches, and etc. And it was a little bit weird here. I believe that's 2 handbags, but I'm not too sure. And then it also thought this person's feet was an actual person. So as you can see, the confidence level here is lower. It's only 87%, whereas here like 90, 99%, 100%. So when we're actually doing this, we can then maybe add like a fine-tuned piece of code to say like, oh, if the object detection model did not have confidence less than 95%, then we're going to remove the image mask, and that would probably increase the accuracy of the model. So if I now change this to 1, we can see that now it tells us like it's processing 1 image, and it's this is the shape of the image, so that's like the size of it, and so on and so forth. So now here's a new image. We have like a bunch of sheep and then a train and some people. I don't know if those are people, but I can't really see clearly right now. So yeah. And then so after that, now we want to be able to use our camera capture to get like a live image from our webcam. So the thing with Google Colabs, the only one bad thing is that you can't access local hardware. So that's why we need to write a JavaScript function in order to access the local webcam. So all this stuff is just importing JavaScript and importing packages that allow us to evaluate the JavaScript code. And this base64 package is this base64 library is going to allow us to convert our images that we take from our computer's webcam into a NumPy array. So this take photo function is just taking a photo, and it's going to call it photo.jpg, and the quality is 0.8. So now we have to write our big JavaScript function to take the photo. I'm going to go over that in just like a couple seconds. Before that, you want to see that after this JavaScript is like displayed, or after we write this JavaScript, we want to be able to actually read it. So we need to do display that JavaScript and then actually evaluate the JavaScript and run the function that is within it. So all this function does is at first we're going to be creating a new element, which is going to be our like video feed, and we're going to be displaying this video stream inside this like little video block. So once I run it, you guys will see. And then after that, we want to show the video feed in the HTML element. So that's why we have to append this child. So the child is just like the append child method is just appending whatever is in div to the document. And document in JavaScript is just the current web page. So we're going to append this document stream to this video stream to the HTML element, and then just play it. And then after that, this is just resizing the output so our image is not distorted. And then this is just for like debugging, just like printing out console.logs to the actual cell of the Google Colabs. Okay, so then in this for loop, this is where we're going to be taking the pictures. So we're going to be taking like 5 pictures here. And first we have to create the canvas of our blank image for now, and then setting the width and the height to the current video height. And then we're going to be drawing an image based off of the current video. And then so what this does is just, it takes the canvas and transforms it into a URL where we can access it later through Google Colabs. And then these 2 things are just for debugging, just like making sure that we know that this line is called when we're sending the command, and then this line is called after the function has already been called. So what this does is invokes the function notebook. It invokes the function run algo, which is defined in the next cell. That's the actual Python call that calls this JavaScript code. So it's pretty messy. It's kind of annoying that we have to use JavaScript, but oh well. And then it's passing in this image array. So the reason it has brackets around it is because this variable is a NumPy array, which will pass into the model to actually do object detection. And then this line of code is just saying we're going to await for 250 milliseconds. So promises in JavaScript are just kind of like I don't know how to explain it simply, but it's just like a callback function that is defined within it. So this is this arrow function syntax shows that we're going to resolve it whenever we've passed 250 milliseconds. So every 250 milliseconds, we're gonna go past this line and go back into the for loop. So we're gonna iterate every 250 milliseconds. So I'm gonna run this to make sure I have it in the scope. And then finally, we're going to actually call the function and take live object detection. So that'll be pretty cool. And then so first we just import relevant packages again. I have no idea why I imported time. It's useless here. But we need to import NumPy as NP and then also import CV2. So CV2 is computer vision 2, which is a package that will allow us to use image assets and stuff like that. And then here we need to import image from PIL. This is the package that allows the images to be passed to Tensorflow and to communicate with it, I think. And then same thing with base64 and logging. Logging is just for debugging, I guess. And then so what this function does is returns the URL of the image and as an image. So once it gets a URI, it turns it into an image. So what we want to do first is in this try except statement, I guess it's like a try catch statement. We want to at first try to find this image once we pass it in, find the URL once we pass it in, and then open the image using this PIL library. And it'll allow us to convert it to a NumPy array after that, because once we put it into image, we want to make sure that each value inside the array is an integer, so it's not like messed up. And then after that, we want to return image. And then if there's like an erroneous or a faulty URI, then we want it to throw an error, so we know what happened. And after that, we have this run algo function. So this is the actual function where we do the object detection. This is the function where we where we get the image. So yeah, so at first we want to get the actual image from this function that we defined above. So that's why we pass in the actual URI to it. And then so if the image is none, then we want to throw an error because there's nothing there. And then after that, we want to try and run the detection. So pretty much very similar to what we had above with the static image object detection. We just want to pass in the image as a NumPy array, and then I just set the verbose tone because I want to see what it's doing. And then visualize results as before. And then this is just in case there's an error. We want to know what happened. So yeah. So what this does is it registers the callback function. So this notebook run algo is like the callback function. This run algo function is a callback function that the JavaScript can invoke to that the JavaScript communicates with, sorry. And then the reason we have to put notebook in front of this is because that's what the Google Colabs thing is like called. And then, so yeah, so this is like the callback string, and then this is the actual function that is defined in this scope. So that's how this thing can call. That's how it communicates with the JavaScript. So after that, we want to actually run the take photo command, the take photo function, and that should work. So let's see. Okay, error. Oh, I have to turn my camera off. Okay, so if I run it, you'll see that it has like a live video feed while it's taking the images, and then it can show, it'll print out all the images. So good thing I'm a person with 100% confidence. And yeah, so just to prove that like it can detect more than just people, I'll like use like a phone. It'll detect this. So if I put a phone in front of my face, it should detect it, which is good. I don't know why it thinks my arm is another person, but that just shows that data machine learning is not completely reliable. So as you can see, it thinks this is a person with less confidence. So that makes sense. We can just filter that out later. But it did detect a cell phone right here, and it can also detect a bottle. Let's run it. So yep, it detected a bottle. So that's good. So yeah, so you guys can like play around with this now and like try different objects that are within the class, that are within the classes defined above. So if there's any object listed here, it should be able to detect it. So I'll give you like maybe 5 minutes for that. If you guys have like any questions or any bugs that come up, feel free to either speak up or just like PM me, and I'll try to help as best as I can. I actually have no idea what a BG is. I don't know what that is. Okay, let's not look at that for now. So yeah, we'll start back up at like 5:50. Yeah, so um, the confidence level is like defined by the model itself. So even though sometimes, even if it has 100% confidence, it might actually still get the image classified wrong, because because the confidence is what the model feels, but it's not what the actual image is, if that makes sense. I don't know if that answers your question. So the question was, can the ML get the image wrong even if it had 100% confidence level? Yeah. And there's like different types of machine learning models that you can use to run object detection. So this RCNN is one of them. There's other models. For example, there's another one called like the YOLO model, which is you only look once. And that model like only looks at the image one time and just tries to get, it tries to just run object detection by going at it once. And so that one is, even though it's very fast, it's not as accurate as other models. So, and also like with data science, the more data you have, the more accurate the model is. So some models that are trained with less image data can be will be less accurate because they don't have as much training data. Because as you can see, there's like a lot of background noise in like these pictures. So for example, if I run it again, see like a random picture. So yeah, so like sometimes like this motorcycle like overlaps with like a car, like a pole here. So then like there'll just be like background and environment noise. So sometimes the model won't be as accurate if you have like multiple overlapping images. So yeah. Okay, so it's 5:50. I'm gonna go to the next part. So in data science, just like a brief introduction to neural networks. Neural networks is pretty much just a black box algorithm that spits out outputs given inputs. So neural network algorithms can be used to create mathematical models that can predict outputs given inputs, so live without like human interaction. So we can teach these models how to do this, so how to predict these outputs given by training them with training data. So essentially we have to give the training algorithm inputs and their corresponding outputs. And so since once we have the inputs and the outputs, the only thing we don't have is the middle, so how we get from the inputs to the outputs. So the neural network will do some number magic, and there's like some different algorithms. So for example, there's one of them that's like the Levenberg and Markov backpropagation algorithm. So these are just like really big fancy names, but essentially what it is just a glorified optimization algorithm. You're just trying to make the inputs converge to the outputs, and that'll make the model the most accurate as possible. So this is very easy because all the human needs to do is find input data and output data and tell the computer what to do, and the computer will find what's in the middle. So for a small project that we're going to be doing this week and next week maybe, is to make a custom image detector. So in order to do this, we need to get image data. So we can use a program called label image to create this data given images. So what we want to do is open up our command prompt or terminal if you're on Mac. So if you're on like Windows, you usually have like command prompt, but there's this thing if you go into the Microsoft Store, you can just search like Windows terminal and it will come up with PowerShell. And this is pretty much just terminal, but for Windows. So what we want to do, the first command is, okay, I want to get into desktop. So what we want to do is get this repository called label image. So I'm going to send this command in the chat. You guys can just paste that into terminal and it should work fine. So you have to type in git clone this, and if you don't have git, you can just go directly to the URL and just download the zip file. So I'm going to do git clone, and so it's going to download and clone into label image. So what this just does is just grabs this file from the internet and puts it into your desktop or your current directory. So right now I'm just in desktop. So it's going to create a new folder called label image inside my desktop and put all this stuff in there. So I'll let that clone for a while. I don't know why my Wi-Fi is so slow. All right, so it cloned, and then so this is the actual program. But in order to use this program, we need to install some libraries. So if you were on Google Colabs, it would be fine. But the problem is we need to download images to our local system. So Google Colabs can't work for this. So what we want to do next is this command, which is pip install pyqt5. This will help us build the label image program. So if you have like multiple versions of Python on your computer, so if you have like a Mac, I think it comes installed with like Python 2.7, you want to use pip3, so it installs it into pip3. It installs it into Python 3, so you can use it on label image because label image only works with Python 3. So since I only have one version of Python, I'm just going to do pip install pyqt5, and I already have it installed, so it's going to say requirement already satisfied. But if you don't have it installed, it's gonna do something similar to this, and it's gonna like just tell you that it's installed stuff. So next, you want to do pip install lxml, and as before, if you have like multiple versions of Python, you should use pip3. So lxml. So this, what this does is it allows Python to like create and modify XML files. So these files are what we're going to be using in the actual training process, which we're going to do next week with TensorFlow. So yeah, so I think LXML comes pre-installed with Python, so most people should already have that. And then after that, what we're going to do, we have to change directory and get into label image. So what we want to do is cd label image, and that will get us into the label image directory. And then after we do that, we want to do this thing here. So this uses pyqt to build the label image program. Nothing should happen, it should just do that, and that means that it's good. So, and if you guys like get any errors or anything while you're doing this, like please let me know and I can help you live. So, okay. So after that, label image should be working. So we can just do Python, and then if you have multiple versions of Python, you should just use Python 3, but I only have one. So Python, label image. What does that one? Okay, yeah, so this one builds the label image project using the pyqt library, I believe. So after we do that, we can just use Python label image.py. Okay. that will open up a new thing. So it should be something like this. So now we can change open directories and save directories. So this is how we're going to be labeling our images. So what we have to do next is actually get the images. So we need to go back to our browser, and we need to google.com images. And so what I'm going to be doing is just coronavirus masks, because that's fairly relevant. I'm going to try to make a custom model that detects COVID masks. And the annoying thing is we don't want to like download all these images one by one. So there's this extension called FatCon batch download image, which we can get on Chrome. So if we search FatCon batch download image on Google and go to the Chrome web store, we can just get this extension. And yeah, so once we have this extension installed, then we can just go and click it on it and click download current tab. And before we do this, we want to make sure in our settings that if you search up download, we want to make sure that this thing right here, ask where to save each file before downloading, is switched to off, because if we switch it to on, it's going to like prompt us every single time, which is going to be very annoying. So once we search download and switch this to off, please tell me if I'm like going too fast or if you need me to reiterate anything. So once we have that, we can just go to download current tab, which is what we have right now. And yeah, so once we do that, we can click download here, and it'll tell us don't select ask where to save each file before downloading, so we have that switched off already. And once we click download image, it's going to download a ton of images at the bottom here, so we'll wait till that's done. And yeah, so download current tab. Okay, so I have this extension pinned right here right now, but if you don't, you can just click this little puzzle piece thing, and it'll show this extension's little toolbar thing. Or you can just pin this extension to your browser, and it should show up. So once you click this, there's a download button that says download current tab, and you just click that. So once we have all those images, we can go back to our file explorer. And if you go to our downloads folder or wherever it was, you can go to masks, and we'll see that we have all these images. So we can just do Control A, and also on the desktop, we want to create another folder, which is going to be our sort of object detection folder. And I'm just calling my folder masks right now. And you want to make sure that you have these three folders within masks: data, images, and training. And then so in data, we're just going to have nothing in there. The only reason I have this is because I was just making a filler file. And then in images, we want two folders called test and train. And you guys don't have to make this folder yet, since we will only be using this for now. But just in case, I do have a Google Drive folder which already has the folders already created. So you can just open this, and that should give you the folder architecture for this. So once we have this folder, once we download it, oh yeah, and in the Google Drive folder, I just have like a filler image because Google Drive won't let me put folders without like stuff in them. I can't share them. So that's why there's like a filler image. You can just delete this once you download it. So we want to put all of our images from downloads inside the images folder. Oh, let me copy it. So we want to put that in there. So once we get all these images in this folder, we want to go back to our label image. So To do that again, we can just go back. If you already have it open, you can just go there. If not, we can just do Python image.py, and it'll open it up. So I'll give you guys like 10 seconds to do that. Okay, so once we get back into PowerShell, we can call this label image.py command again, and this will open up label image. So once we get into here, we need to change our open directory as well as our save directory to be the images folder that we defined before. So for me, I just have it on desktop, masks, and images. So if we click into, we have to click select folder, and then we also want to change our save directory to be the same one as that, because we're going to be copying everything into here. So once we get these images, we can start labeling them. So this one isn't too very high quality. It's kind of, the resolution isn't too high, so I'm going to switch to one that's better. Let's do this one. So in order to label them, we're just going to click W once. You don't need to hold it. And this will open up this little cross thing. And then we're going to click and drag to create a label. So click and drag and then release. And then this little prompt will come up and it'll ask us what we want to label this class, this object as. So I'm just going to call this mask. Click OK. Then after that, I want to save it. If I forget to save it, it should prompt me to. So I want to click yes to save the label. And then I don't know why it has these. So how do we select image? I think if you already, like if you open the label image program before you copy the images in, you probably have to restart it because it hasn't updated with all the images yet. So you just want to like quit and then go back in and then use the Python label image.py command again. And that should open up the label image and then click open directory to select the correct directory again. And yeah, and then make sure to change the save directory as well. So, okay, yeah. So, and then if we come across like an image with like multiple masks on it, then we can create many different labels. So I can call this one mask. I can call this one mask. And we just press W again to like label another mask. So I click W again, and then click and drag. So this part of the like training the model task is kind of tedious because it's just like busy work and we just have to label these. So over this week, if you guys don't want to like spend like hours labeling a bunch of images, that's fine. I'm probably going to be labeling a bunch of these masks, and then I'll just give that to you guys at the beginning of the next workshop, so then you can just use that for training the model. But if you want to like train a model to detect your own custom image, then you'll probably have to go on to you'll probably have to get some images and label them. So yeah. And also just to let you guys know, to have an accurate model, you should probably have around 100 to 500 labeled images, so quite a bit. So once we label these images, you just want to click save and then go to the next one. And then say I'm like done labeling images, then I can just press X and then it should quit and auto save. And then if you go back to the terminal, you can see that it told us that it converted these JPEGs to the XML files. So that's good. So now we have XML files that we can use for the training, which I'll cover next week. Yeah, you can press W to select the image. And then if we go back into our File Explorer, you can see that we indeed have created XML files. So that's good. And yeah, I think that's all for today. So next week we're going to be training the actual model once we have all the images labeled. And also, if you guys have any feedback or any suggestions or anything on these workshops, you can use the Google form to give those feedbacks. So yeah, and I will post the recording of this workshop later on YouTube probably, or maybe on Slack, as well as all of the resources. So yeah, Thank you guys for coming, and have a wonderful evening.